Hello everyone, my name is Pengliang Zhao, and this is EEL 6509 project presentation. My topic is Simulation and Performance Analysis of OFDM system. OFDM, which is short for Orthogonal Frequency Division Multiplexing, is now the key technology for mobile communication system, especially in the 4G network. This project will analyze the modulation and demodulation of the OFDM system. Also, the project covers some key elements in the OFDM system based on the given system model. And the system is computer simulated using MATLAB. Besides, there are also some analysis on the performance of the OFDM system. The influence of CP and the channel estimation of the system performance has been analyzed. In the condition of gas and relay feeding channel and synchronization. This project gives a computer simulated with MATLAB language. The project gives a rational design procedure of simulating the OFDM system. Here what comes about the problem. To design an OFDM system, there are some key technology indicators. All the indicators are listed in the table 1. The digital signal processing technology used in this system is IDFT and FFT. FFT is short for Fast Fourier Transform, is used to design the OFDM system. And this OFDM system is based on FFT and IFFT. When it comes to channel estimation, the pilot frequency is used. Finally, MATLAB will be used to design the whole OFDM system and test the performance of the OFDM system. Impact-based solution details from the report, the original theory of the OFDM system, how to design an OFDM system, and how to analyze the performance of the OFDM system discussed in details. A solution put to the problem. Based on the given system model in the project, the system is computer simulated using MATLAB. And we also analyze the influence of CP and the channel estimation. MATLAB code. In the MATLAB code, 10 images has been displayed. The OFDM signal in frequency domain, carrier phase, separate time waveforms carrier, time signal in one single period, OFDM time signal, OFDM signal spectrum, OFDM received spectrum signal, both in phase and magnitude, and also the OFDM constellation diagram. Because the code is very long, so we're going to say it in the MATLAB. Here is the MATLAB code. We can see some key parameters in this OFDM system, like the number of sub carriers is 200, and the sample points of the FFT is 1024. Bits per sample is 2, and the samples per carrier is 20, and then the signal to noise ratio is 10 dB. Here we can see which images has been displayed. We can see it here. Here we display the OFDM carrier frequency magnitude. This is OFDM signal from the transistor. From the transmitter. And the second figure here we can see is OFDM carrier phase. This is carrier waveforms in phase, shows the OFDM carrier waveform structure. And then we're going to say the third image is OFDM time signal in one sample period. And the fourth image will be the OFDM separates the 4 time waveforms carriers. All these 2 images are about the carrier waveforms of the OFDM system. Here is figure 5. Figure 5 shows OFDM time signal. This signal is the signal that's transmitted in the whole OFDM system. And this is figure 6. This is the OFDM signal spectrum. We can see the OFDM signal in the spectrum. And figure 7, here we are in the receiver, and we can see the OFDM receive spectrum in magnitude. And also the figure 8, we can see the OFDM receiver's spectrum in phase. Both these two images are very, very important because this is the receiver, and we can see how the OFDM signal can be received, both in phase and magnitude. And then we come to the figure 9 and figure 10. In this, we're going to talk about the cyclic prefix, the CP. And as we all know here, we're going to discuss the CP because CP is very good to eliminate the influence of ISI. And here we're gonna here we're gonna say that we use simulated by MATLAB show the signal after QPSK modulation. And after the modulation, if the CP is much more smaller than the delay in the channel, there may be no distortion in the signal. But if the delay is longer than the CP, there will be some distortion in the constellation point, constellation points, and we're gonna see the result in the program, in the PPT. And we're back to the PPT, and here is the first image, the OFDM carrier focus magnitude, and these images is about the carrier waveform. And the second, the OFDM carrier phase. Third, we can see the OFDM time signal, one sample period. And we can see the separated time waveforms carriers and the OFDM time signal. And the OFDM signal spectrum. And here, we're going to say this is the OFDM receive spectrum. And this is very important because from these pictures we can see the OFDM receive signal. And here I want to talk something about the channel. In the OFDM system design here, the channel here is the Grayson and a real light feeding channel in an ideal synchronization condition. The delay here in the channel is 1. And each single signal in the receiver will do a FFT transform. And this picture is OFDM receiver subspectrum in phase. These two images shows us the real received OFDM signal. And here we can see each sample distribution image 1 and 2. In the image here, the CP is smaller than the delay in the channel, so there is no distortion in this image. But we can see this image here, this image 2. We can see that if the delay is longer than the CP, there will be some distortion in the constellation points, which is that CP really could help us to eliminate the ICI, but they also can cause some distortion to the whole system. So, if there may be some distortion, why still CP should be used? And here I want to discuss that if the CP is 20% of the OFDM signal, the loss of power is lower than 1 dB, and the loss of signal rate is about 20%. However, the CP could help to eliminate the ICI. The loss of the power and the loss of signal rate are mostly here when we're using the CP in the OFDM system. Now we come to the conclusions. Here we know that OFDM technology is very important in the modern mobile networks. The the performance of the OFDM could be improved by a better channel, which means delay is small and minimize noise in the channel. The CP, cyclic prefix, could help to eliminate the inter-channel interferences. Even considering about the loss of power and the loss of signal rate as discussed above, the CP in the OFDM system is necessary. We could also eliminate the interior symbol interface ISI by using GERD interval GI. And thank you for watching this PPT. And now we're going to come to the program. And as I have already discussed and explained the program, we can now run in this program. Here we got the 10 output images. We're going to show it. Wow, here we can see the OFDM carrier frequency magnitude. And the second image is OFDM carrier phase. We have the third image here, which is OFDM time signal in one sample period. We have the fourth image here is the separated time waveform carriers. And image 5 is OFDM time signal. Image 6 is OFDM signal spectrum. Image 7 is OFDM receiver spectrum magnitude. Image 8 is OFDM receiver spectrum phase. And here we got these two images. We can say in the image 9 there is no distortion. But if the CP is longer than the delay in the channel, there will be some distortion like in the image 10. And thank you for watching my presentation. Thanks a lot.